So if you at any time you can't see my graph paper, let me know, okay? So when we were looking at the PowerPoints the other day, one of the things that popped up, you know, one of the first things it said was to look at this line. So what I did was I went ahead and just drew a line on my graph paper, and I labeled each end A and B. And so what we're going to do now is we're just going to draw a line. I'm just going to draw a straight line. I'm not measuring it. It's just going to be a ray. And I'm going to label this ray PQ. And I got to have an arrow on the end. And I want you to copy this line to this line. And the way that we do that is, I'm going to try to keep my fingers out of the way, is you put one end of your compass on the point end on one corner, one point, and the other one on the other. Don't move it. And then I'm going to come down here and I'm going to put P right. I'm going to put my point on P. Does everybody see that? And then I'm just going to swing an arc. Now, this one can be called R. So now AB and PR are congruent line segments. And they're line segments because they have a point on both ends. Does this make sense? Give me a thumbs up or something. Okay, no thumbs up? Yes, maybe? Okay. So what's happening here is, thank you, Jordan. So if you were to take your ruler, and I'm just using the bottom of my protractor, and I measured this, and it is 1 inch. And I'm going down here, and I am measuring PR, and it is also 1 inch. And so that way we know that we have actually duplicated these two, and we can label these and say that line segment AB is congruent, it's the equal sign with the little wavy line on top, to line segment PR. And this is how we would show that. So if we use this same line here, AB, and then I'm going to draw another line, XY, and then I'm going to draw another one, CD, let's say. The first thing we're going to do is we're going to measure line AB, and we've already done that here. But what we're going to do is we're going to do that again. So we're going to draw another line. Well, hang on, sorry. Let's keep this one and we'll call this PR. I'm trying to do what they did in the book, but I am not following their direction. So let's just go ahead and do, if we draw PR, and then I come up here to measure XY. Okay, so what's going to happen is then I'm going to measure XY just like this. And then I'm going to do CD. And from CD, I'm going to measure out. Should have done CD first, peoples. Hang on. AB. So this is going to be PQ. And if we look here and go to the end of PQ, and let's draw our CD line at the end of P. Then let's go to XY and measure XY. And I'm going to come here, and I'm actually going to draw an arc here. And you can see I didn't measure out, so everything's going to look a little wonky. But if I draw a line up from here, then I've drawn a triangle because I've done the intersecting lines here and here. And those are the same lengths as what I had up here at AB, XY, and CD. So this CD line, and it's not the same measurement. It should be out there. I should have measured this one. Sorry guys, this is my favorite part of the class and I'm goofing it up for you. Let's go to step 2. So we're constructing a angle now. So just get a straight edge and just construct a ray. Now I am doing my book and it says to construct arcs of the same radius centered at D and at Q and let E and F. So what you're going to do is you're going to construct an arc and they have an angle in the book. So if you just want to draw, it might just be easier just to draw an angle if you don't have your book. I'm on page 619. So if you have an e-book, it's going to be hard for you to do it. So I'm just freehanding a drawing of an angle here. Okay? And they label theirs in the book D. And I'm on page 619. In case you have a book. If you don't, then you can just print this off later. But what you're wanting to do is come here, and we're reconstructing this angle. Now, I am not at any certain place, but do you see I am just drawing an arc over both of these angles here, over both of these rays. So what I'm going to do is come down here to mine, and I'm going to do the same thing. I didn't change the length of it. And you can see my protractor. I didn't go buy a new one. I found my son's upstairs that who knows how old this thing is. Now, so we know how the angle is here because we've done an arc here. The question is, how do I draw this other line, this other ray? So what you're going to do is you're going to put your point on one end of the arc, and then you're going to put your other pencil point or the other point on the other end of the arc. And then what you're going to do is you're going to draw a line, and I'm going to have to hold mine a little weird. And what's it going to do is it's going to make like an X right there. So making sure that it's the same, I'm going to come down here now, and I'm going to draw an arc across this other arc that I just did. Using my straight edge and a pen, I am going to go from my point, and I'm going to cross over where I intersected my arcs. Now, it does not matter if these rays are the same or the same length, because remember, this has got an arrow, and this arrow keeps going, so that means it's going to stretch this ray out. What I'm most concerned about is this angle measurement. And so as long as this angle measurement is here and it's the same as this, then we're okay. So if I were to take a protractor and I were to measure this, this would come out to be about 35 degrees, and this one's going to be about 35 degrees too. So you have reconstructed an angle. We just drew freehanded an angle, and then we actually reconstructed here on the side. Now, if you were to, on page 624, try to use a different color pen. On page 624, they use that theorem, Thales theorem, that says that for any semicircle, so if I have a semicircle here, and I just use the inside of my protractor, as you saw. And this is that theorem that says whatever point I put here, so whatever point I draw on this, wherever I draw a point here, so if we have A and B, and I draw this as point C, and now I connect my points, and I look at this, then these are going to be, and they're not quite to the point where they need to be, this is going to make a 90-degree angle in here. So if I were to measure that, and that's that Thales theorem on page 624 that states that. So if you want to try those out and look at that, that'd be great. Now I'm moving to 12.2, which is actually where all the construction and stuff was actually at. So when we are doing this, we are actually going to be constructing the first one. We're going to be constructing parallel lines. So if you're given, let me put up here, I'm going to try to do this close to the top because I can use this whole paper for this one. So if we're given a line here, and I'm given point P, then they're asking me to draw a parallel line to point to through point P to line L. Now remember, parallel is going to go this direction, not this direction. That's perpendicular. So we're drawing a parallel line. So in order to do that, is I am just going to pick a point on this line. We're going to call this point A. And then from point A, I'm going to measure to point P. And I'm going to draw an arc. And we're going to call this point here B. So now if we draw, now I know this is not parallel, people, so you don't have to tell me this. I'm going to draw a line here. And I know that with this line, because I just measured it, this line AP is congruent to AB. And so I've got this point here, this length that I've done. Now I'm going to come to point B, and I'm going to draw an arc from point B out here in space. And at point C, I'm doing the same thing. At point C, at point B, at point P, blah, blah, blah. Sorry. So I measured, again, I measured, the first thing I did was I picked a point on my line, and it didn't matter where, and I measured from A, from the point on my line to point P that was given. So I was given P and line L. This was a point P and line L. And I want to draw another parallel line through point P. So I just picked a point on my line, given line, measured it to point P, and then with that measurement, I just drew an arc down to my line. And that made me, when I drew this line, that made AP congruent to AB. With this same measurement now, I went to P and I drew an arc. Then I went to B and drew an arc. And now I'm going to take my protractor, and I'm actually going to go from through point P and through my crossing that I have and draw my new line. And this line is parallel to my given line. Now I know that seems like a lot of work to do, but that's how we're doing it. Now, let's say we have the same given line. I have a point P, a line L. Now I want to draw a line that is perpendicular to this, not parallel but perpendicular. So I'm going to do the same process. I'm just going to pick a point on this line, and I'm measuring this. Now, what I'm going to do now is I am actually going to swing. I'm going to point P. I went to point P here. And I'm actually swinging an arc. And it's hard to do. I'm actually swinging an arc all the way around. So it's cutting from both sides of here. So the point over here, this one I'm going to label A, and this one I'm labeling B. Now remember, I started out by measuring just a point on the line. Then I went to point P and I did an arc across my line that was given. And now I'm going to go to point A. And at point A, I'm going to draw an arc over and then I'm going to go to point B and I'm going to draw an arc. Now I know these two arcs don't cross right here, and the reason is because I'm going to go from point P and go through where I just did my new arc, and this is my perpendicular line that I just drew. So any questions so far? Are you still seeing my graph paper?
Yes, I am.
Any questions?
Nope.
Okay. So this is when we have a parallel line and a point given that's off the line. What happens if I want you to draw we're given a line and it's line M. And let's say that you're given a point here on the line, and we're going to still call this point P. I want you to draw a perpendicular line through point P. Now, on graph paper, it's very easy to do, but if you've got white paper or no line paper, then that's going to be a little bit harder. So, the same thing goes. Just pick a point on this line, and I'm going to call this A again, and I'm measuring from A to P. I should do it like this, from A to P. And so what I'm going to do is actually flip it now and come over to P and draw an arc where I'm at. And we have B here. So now, and the reason I did this is I want this to be the same distance. So now I'm going to come out and I'm going to draw this arc. I'm going to stretch this out a little bit bigger than P, you can see. And I'm actually going to draw an arc. And I know this is not how you hold a compass, but you can see I'm drawing the arc pretty big. And then I'm going to come over to point B, and I'm going to draw the same size arc. And this is, so I first picked a point on the line. This was my given point P. I picked another point on the left side of P, and I drew another point at the same distance on the right side of P. And then I went back to A, and I actually stretched out my compass a little bit and made it larger. So I wanted this distance to be further than P, longer than P, and I drew an arc. I went to put the point on B, and then I ended up drawing an arc in the other direction. So now when we take our protractor and I go through point P and I connect my arc crossings, then I've made a perpendicular line to line M, and we'll call this N, or let's call this X. It makes it a little bit easier. So line M is perpendicular to line X. So any questions? So this is all I wanted to show you today. There are other things that are in the book, doing an angle bisector, and that means that when you draw a triangle, that you actually draw a line that splits this angle. So if this was a 30-degree angle, then I would draw a line here that was at 15 degrees, and another one would make 15 degrees, and this angle bisector would come out. And that one is pretty easy. So if I just drew an angle on my line, and I have a point on one line, and I'm going to draw this arc. Then you see this arc here. Then what I'm going to do is come out and draw this arc, same distance, but I'm going to my point. Sorry, you can't see that. So I drew a distance here. I made an arc here. I'm going to one of the points on the angle and drawing an arc out here, and doing the same thing. And now I'm going to connect from my vertex of my angle to where I crisscrossed my arcs, and this is called an angle bisector. So that one is pretty easy to do, and if you were to measure it, then you would know that this angle is the same as this angle if I had drawn straight lines and made everything look really pretty. So any questions about that? Can y'all still see my screen?
Yes.
So we just did some constructions. We did not construct the rhombus that was right here, but you can see that it's pretty much the same way we were doing the angle bisector. It's just that you're drawing, because the rhombus is just like a square that kind of put on its brakes extremely fast. And you can see that if I were to draw an angle, it says the diagonals are angle bisectors. So all I had to do was really do a bisector and then connect all my angles, and it would actually be done. So for a rhombus, they're angle bisectors. They're perpendicular. So if you see in the very center of that diagram, AC is perpendicular to BD at point M. And when you draw this, even though the angles are not the same, opposite angles are, but all the sides end up being the same length. And opposite sides are parallel. So there's a couple of ways that you could have drawn a rhombus. You could have done two parallel lines. You could have done angle bisectors. So, you know, there's several ways, and this next couple of slides are going to be how to do angles that are lines that are parallel and perpendicular that we just did. And then doing an angle bisector, which is the last one that we just did. Guys, I don't, Fermat prime numbers I don't talk about, so I will, any questions with that in it, just if you get it wrong, I'll go back and make them correct. But some of those, they have questions, and then they add the Fermat primes, you know how they do in part C or whatever. So just answer it, and then I'll go back in and correct it. But we don't usually do the Fermat primes. And that's what a power of 2 multiple of a number that is one of the types from 1 to 3 above. So multiples of the power of 2 is what the Fermat primes are going with. So that's what that means. So this constructibility theorem that he's got. The main thing I wanted to talk about today is similar triangles. And similar triangles I'll let you look at this. Similar triangles, A, B, and C is similar to triangle D, E, and F, and they're written with exclamation point, A, B, C, and then a congruent symbol, just the little squiggly line, exclamation point, D, E, F, if and only if the corresponding angles are congruent, and the ratio of lengths of corresponding sides are equal. And we're going to look at those, but something to add to that is saying that angle D, and the reason they have these down here, that angle A is congruent to angle D, and angle B is to E, and C is to F, is because these are written A, B, C. So A corresponds to the first letter that's written of this other triangle, D. B is the center, so E is the center here, so those two are congruent. And C is the last one, so F is the last one. So these could actually be written in a different order if the angles are different. This is a triangle, but these triangles are written so these angles are congruent. And this is saying then that DE, side DE,